mutually exclusive. And that only means that the Venn diagram should look like that. There is no intersection between two events. So hence we say that if this is E1 and this is E2, and then we would say that E1 and E2 are mutually exclusive. Another way that we would try and find this is for us to look at the probability itself. The probability of the intersection to happen, and of course if you look at it, it's 0, obviously. And why do we know it's 0? It's because of our definition. It's of our definition of what probability is, because we understand that probability is the number of what we're looking at, which is the intersection, and the total number we're comparing it to, which in this case is the universe. And you see that there is no intersection. It means that this number over here is 0. And this one, of course, is a constant. And 0 over a constant is a 0. So that only proves to us in great detail what it is 0. So these are defined as tapes. Mutually exclusive. Alright, but on the other hand, I'll just turn it off for a while. This is really nice. This is really nice. On the other hand, you have independent events. And these are the cases of coins, right? Maybe if you're teaching, if you're teaching in high school, most probably. If you're teaching in high school, you might have asked a student, what's the probability of getting one head in 2 flips of a coin? Right? We've been asking about the situation for our students. And how do we do that? Well, normally what we do is we try to list down all the possible things that can happen. This is the easiest way we can do this, but there is a more better way that I'll just show to you. So what we tell our students is to list all the possibilities down. And the reason I want to show this is because of the independent thing. The possibilities would be, well, both are heads. It's one possibility. The other possibility is this one is a head, and this is a tail, and this one is a tail, and this one is a head, and this one is a tail, and this one is a tail. But we also need to get the probability of this happening, heads and heads. And we do understand that heads and head is a half. And we will prove that. What else I kind of have to say? How do we prove that the head is 1/2? Is it just because of the intuition that we know it's 1/2? If I ask you to flip a coin right now, 2 times, what would you get? Let's see, let's start mathematics first.
Sabay-sabay yun yan. Ay, sige, sir. Ay, sir. Sir, sir. Ano yan mo yan? Ready, go!
So, yellow.
Bali, Oo. Salita niyo, sir. Ako naman taga-pulot siya.
everybody was trying to aim at the circle. Right. I wanted it to be a random throw, but it seems to be the game in the circle, so we would have a calculation that would not arrive at what we want, but then we will still try it out. So how do we solve the probability based on this few number of pixels chosen? These are very few number of pixels chosen. This is not the actual pixels, but only a sample. And we will see if the sample is good enough to calculate for pi, but I don't think so, because we focus on the zero. But let's just see. Let's count how many is in the zero. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And obviously there's only 3 on there. So it means that on the square there is 29 days. So how do I get the probability? Circle over square. Probability of pixel on the circle is equal to on the circle over on the square. Square is the total. So 26 over 29. Oops. It's hard to see this on the video, so that's right. And can I simplify that? No, can I simplify that? Okay. What's that? 26 over 29. Let's use my calculator. If you have a calculator, let's try and use it. Or you can solve it randomly if you want. 0.9. Oh, that's nice. And then how do we get pi? Almost. It's pretty good. So we do get pi. Is that how the Egyptians Greek got pi? No. They didn't have any idea of probability. They do have, but it's not as complicated as this. What they did was using areas of triangles to get the value of pi. But for our case, we're going to use probability to get the value of pi. So now, instead of doing it manually, we're going to try and use Excel to try to do random points, and we will see where it lands. Right? So here we go. How do we do that? That is a mathematical problem, and we will solve it and see what we can do about it. Give you an idea of how to do this in an automated way, and that's what we're supposed to do in the master's level. But not only that, we learn the underlying concept of probability, but how do we expand our knowledge, because that's what it's supposed to be. Alright, so we need to automate what we're doing. What are we doing? We're generating, what do we do here? We threw points, right? We threw a point and put the point where it landed, and hence we're trying to generate random points. Now, when we're teaching mathematics, we understand that that this itself is a two-dimensional object, which means that we can represent it in a Cartesian axis. And I do understand that you already have your geometry before this. So it would be quite, when was that? Just like last month. Analytical geometry. So it would be okay if we do some calculus today. Let's just try it. And it means that we can represent this in the Cartesian axis. So this is what I'll do. have my y-axis here. And the x-axis is there. And the reason I'm doing this is I wanted to try and do this in an automated way. So I need to translate this in a more mathematical form to idea. So what are these points? If this is a Cartesian axis, these are points, right? Which is now represented, a while ago it's pixels. But now I changed it into a mathematical form. So what is it now? X and Y. Alright. So the thing I need to do now is to make sure that I can randomly generate an X and a Y. Right? On my Cartesian axis. And in this case, each X and Y would have a particular number for y and a particular number for x. And in that case, if I call this xi and y effect, so this would be xi and this would be y effect. Now, I don't want to make it more complicated than it is, so I would limit this area right here for the square to be 1. And here is also 1. So it means that the points that I generate should be, alright, that's okay, should be less than 1 and equal to 1, because it needs to also be there. And let's not forget the origin. So the points that I need to generate should be this. Random points within this, in this case, and I call this a range. Because strictly speaking, I cannot call X a range. Right? So let's just go with the mathematics in that domain and that range. Just say that in this domain and this range. So we need to generate those points. The next step is we understood what we're supposed to do, right? We're supposed to do that. But the next step is to change this mathematical language into a computational language. And computational is programming. But we're not going to use a serious programming tool, we're just going to use Excel. So everybody's programming with Excel anyway, right? But have you ever tried using Excel for this kind of situation? So if it's the first time, it would be cool. Alright, so let's try that. Unfortunately, I will be erasing the circle, so I need to draw it because I will be having an Excel on the other side. So I will just retrace this before I remove it. Mathematically, and how to do it. Just, I'll do this here so you can. Alright, this is my suggestion. Let's have the circle having its origin center at the origin. Like, how does geometry teachers draw shapes? Do they use rulers? It's just natural. Can you show me? But just so let's use this. I don't want the video to see this. Can you? Alright, so let's do that for HK of the circle is 0, 0. And we forgot to draw a square one. So now I will draw a square, and I hope it doesn't look bad. I'll see, look at that. I don't know why that happens. I'm destroying the quality of the circle. It's a trapezoid. Okay, so by doing this, if I have a point x, y, I would now know where it is, one side. I would now know whether it's inside or outside by having this strategy, y. Because I can calculate for the distance, and if the distance is less than the radius, I know that it's inside the circle. Isn't that much better? And to make it much easier, why not have just 1/4 of the circle, right? Remove all of this and just have this, which is also a square anyway, and a quarter circle, and have the points generate of this, and calculate for the radius of the point. So let's determine the radius. Maybe let's try 0, 1. And why is this okay? Because whenever I get here, I just multiply by 4. Right? So that's what I'll do, to minimize the work that I need to do. And anyway, we'll try to ask the x sub to the y sub. And then we'll generate random points in here. And you see that no matter where it is, we can calculate for the distance from the origin. And you know that it is outside when it is more than the radius of the circle. Seems to be promising, so we'll try this. Now, how do we translate this into computational? Into mathematics, and here is the computation. So we'll try that. How do we